Okay, for this one, we're going to merge a sorted array. You're given two integer arrays, num1 and num2. So our inputs are going to be two integer arrays, num1 and num2, num1 and num2. It's also sorted in non-decreasing order. So it's going to be sorted in increasing order. And two integers, m and n, representing the number of elements. Oh, so we also have two integers, m and n, representing the number of elements in nums1 and nums2. So what we have here is we have two arrays, nums1 and num2, with numbers in non-decreasing order. So 1, 2, 3, 0, 0, 0, 2, 5, 6. But M and N are the numbers representing the elements that's in those arrays. So we have 3 there. So the M represents 3, and then this represents 3. And then we want to merge 1 and 2. So merge this with this, or merge this with this, I'm assuming, into a single array. Yeah, merge nums 1 and 2 into a single array. The final sorted array should not be returned by the function, so we are. Oh, wait, should not be returned? Why? Oh, it's void. So we're not returning anything. Instead, we're putting everything into nums1. To accommodate this, nums1 has a length of m plus n, where the first m elements denote the elements that should be merged, and the last n elements are set to 0 and should be ignored. Okay. So what this pretty much is saying is we have two arrays, um, nums1 and nums2. So what we have to do is use this array. So it's going to be in place, I guess you can call that in place property, because we can't use any new data structures. So nums1 would be updated in place using nums2. And nums1 has enough space in it for nums2. So what we need to do is combine 1, 2, 3. This is 2, 5, 6. So it would be 1, 2, 2, 3, 5, 6. And that would be combining or putting this inside of this and keeping the non-decreasing order. So one way we can do this is, let's see, we'll use 2 pointers. Let's see, one way we can do this, we're going to use 2 pointers because I want to read from nums1 and I want to read from nums2. So I'm going to have 2 reader pointers. I'm just trying to decide if I want to do it from I think it's going to go from the back. If I start a reader here and a reader here, I'm able to compare those. Yeah, I can do it from the back because this is going to be filled up with the greater numbers towards the back. So I'm going to have a writer right here, a reader right here, a reader right here. The 2 readers are going to compare those, and the largest ones are going to go from the back. So if it's going to go 3 and 6 here, it's going to compare those. 6 is greater than 3, so I'll write that here and move this and move 6 to 5, and then compare 5 and 3. 5 is greater, so I'll move 5 there, move the 5 to 2, and continue going down the line. So that's going to be my algorithm. So like I said, I'm going to have int reader1. Let's do reader nums1. Let's just do reader1. Int reader2. And then we're going to have a writer. No need for that. Oh, also we're going to need to know when this is done. So it's going to be a while loop. So as this is iterating backwards, if this run, well, yeah, that's how we'll know that's the stopping condition, when this is done. I'm trying to see. So it says 3 and 3, but what happens when you have 0 and 1? So this would just be done. And then this one would be 0. So we also have to consider if there's no numbers in nums1, what do we do? So we can continue this as long as there's numbers in here. And then the same thing this way. We'll continue writing as long as there's numbers there. So those are two gotchas right there. And then writer is going to equal m plus n minus 1, because we know that m plus n is the length of the array, and minus 1 will put us at the end of the array. And we want to start this reader right here at nums1 dot length minus 1. So we're going to put that at the end as well. And then same thing with reader 2, nums2 dot length. I spell that right, ng minus 1. And just make sure that's right. This wouldn't be minus 1 because this is going here. So this would just be that m minus 1, put it 2, 0, yep. So we'll do that. This would be m minus 1. And then, could this be n minus 1? Well, technically it can. But we'll just keep it consistent. So do n minus 1. Then m plus n minus 1. We're good there. So like I said, we want to do this while there's numbers in here, and then also while there's numbers in there. So we'll start with while. What are we doing? While we need to compare our readers. So we're looking at nums2. What I'm saying, as long as reader 2 is greater than or equal to 0, because reader 2 would start here, here, and here. And as long as it's greater than 0, we can continue going, because once it's less than 0, there's no numbers in there, and we can just that means we're done. So what we're going to do, like I said, we're going to compare those indices. So I said if nums, we'll do nums1, we also want to make sure that there's numbers in nums1 too. So in this case, there is no numbers. So if, how am I doing that? If nums1 we say does not equal 0. Let's see, how do I want to do that? Because we also have to make sure, so this, the reader 2 greater than equal to 0 covers this case, but you also have to cover this case as well. Meaning, such as this one, there's no numbers there, so it'd just be this. So that would be, as long as nums1 is not equal to 0. This is just throwing me off here, because even if you have 0 here, there's technically a space, but there's no nums1. So I'm wondering, should I just do m? Because if reader, oh, it can be greater than 0, because if reader is m minus 1, that would put that to negative. So as long as reader 1, I think, as long as reader 1 is greater than or equal to 0, I think that should cover it. I hope that's it. Because what I'm thinking is m is 0. If I get m minus 1, that would be negative 1. So that means that there would be no numbers, and we can stop there. So let's try that. So if reader 1 is greater than or equal to 0, and what are we looking at? We're comparing nums1 at reader 1 is greater than nums2 at reader 2. So if that's greater, then what we'll do is put that towards the back. So writer, no, what did I do? Oh, it's reader 1, no, nums1 at writer would be equal to the greater one, so that would be nums1 at reader1. And then we can decrease writer, and then decrement reader as well, reader1 minus minus. And then we can do else nums1 at writer would be reader2, nums2 at reader2 instead. And then we can still do writer minus minus reader 2 minus minus. And yeah, both of those are writer, but I'll just keep it explicit. Well, take it out of there. Writer minus minus. There we go. And I think this might be it. Let's just see. Expected. What did I do wrong? Nums1 dot length. Oh, because I put both of these. Alright, what else did I do wrong? We are in the green, so hopefully no crazy cases, edge cases. Alright, we are clear to go.